All right, today we're going to talk about 7.2, which is looking at the different properties of parallelograms. And when we break down these properties, we're going to look at how they have different side properties, angle properties, and with the diagonals. So first off, the side properties. With a parallelogram, we are going to have both sets of opposite sides are going to be parallel. And so we can see that marked in the diagram, like so. We would also have both sets of opposite sides would be congruent. With the angle properties, we would have the fact that opposite angles are congruent. And then also that because of the parallel lines, we would have consecutive angles would be supplementary to each other. And then the last property is dealing with the diagonals. So when we have a parallelogram, the diagonals bisect each other. So when I draw in the diagonals, on each diagonal they are bisected. So I have congruent segments there, and those two segments are congruent. So I can use these properties now in anything I do with parallelograms, whether it's in proofs or in algebra. So with this first proof, starting off with the fact that I am telling you that it is a parallelogram, so we can use all of those parallelogram properties. A, B, C, D is a parallelogram, and you'll see that abbreviated for a parallelogram. I see that AD is already mentioned, so I'm going to try to bring AD in. Since it is a parallelogram, I can say that AD and BC are going to be congruent. And that is because a parallelogram tells me that opposite sides are congruent. Bringing in my given statement of BE is congruent to AD. I then can use the transitive property connecting BE and BC together, because AD linked them together. So with the transitive property using steps 2 and 3. And then when I look in the diagram, I see that I have those two sides congruent. So I can say that angle 1 is congruent to angle C because sides tell me that the opposite angles are congruent. If each quadrilateral is a parallelogram here, then find the different values for x, y, and z. So we need to use the properties that we have here for x, y, and z. So go ahead and take a moment and pause the video and solve for x, y, and z in each of these. So in number 1, alternate interior angles tells me x is 29. And then within that triangle, I can find out that y is 73 and z is supplementary, so it is 102. For number 2, opposite angles are congruent, so z is 105. And then with parallel lines, I have alternate interior angles. So x is 31 and y is 44. For number 3, I have opposite angles are congruent, so x is 73. I have consecutive angles are supplementary, so z is 107. and then y would also be 73. We can look at finding things within a coordinate plane as well. So finding the coordinates of the intersection of the diagonals of parallelogram ABCD. B is at 6, 0. C at 5, 3. And D at 0, 3. The intersection of the diagonals so drawing in the diagonals, because those segments are going to be congruent, then that means that the intersection point there of the diagonals must be the midpoint of AC. And so when I find the midpoint, add up my x's and divide by 2, and then add up my y's and divide by 2, and I get that the midpoint is 3, 1.5. Find the coordinates of G given the vertices of this parallelogram. So we're given 3 of the 4 vertices. Let's actually screwed that one up. So D is going to be at -1, 4. E is at 2, 3. F is at 4, -2. And I need to find G. One thing that we need to remember when we are looking at this is the fact that the opposite sides are parallel. So the slope of EF has to be the slope for DG, or the slope for GF has to be the same slope as DE. So when I look at this slope, if I find the slope of DE, I get -1/3. That means that the slope of GF must also be -1/3. So if I were to go back 1 and over 3, I would be at 1, -1. And I could verify that that is true if I check out the slopes of the other lines. So if I were to check out the slope of EF, the slope of EF is -5/2, is going down 1, 2, 3, 4, 5, and then over, 1, 2, 3, 4, 5, and over 2, I get to the same point. So both pairs of opposite sides parallel using the slope get me to the same point. So 1, -1 is the coordinate for G. And then the last proof can be done on your own.